Okay, guys, we're kicking off the third and the last stream of the day. We're gonna wrap up a couple more dataset loading tasks, and then I'm gonna write a document on how this whole thing works on some level of detail, and then we can slowly improve it. It can be maybe useful for some of the beginners and people who want to come and contribute to have a bit better documentation of how our dataset loading works. And that's going to be the first set of tasks, and then I'm going to start piling up some tasks for it might be good first task for the community. Let me again, as usually, just share the link to the stream. We're wrapping up day 17. A lot of work over the last days. Really productive. Last stream of the day. Wrapping up data loading analysis plus writing the community tasks finally. Okay. Let's go. Let me turn on the live chat so I can see your messages, and let's start. First thing, I just want to see where we add this end of sentence token. I didn't catch that quite while we were doing while we were creating the data set. So here's how it looks like as a quick overview. So we find the bin and IDX files. We use that to construct mmap. We then wrap it into prepend token dataset, which is going to prepend the language token as a prefix, both for the source as well as the target sentences. Then we basically wrap those up in the language pair dataset, those two source/target datasets, and then basically we wrap multiple of those for each of the language direction inside of the sampled multi-dataset, and we assign a sampling ratio to them. Okay, we can additionally even upsample, and then create this virtual size for dataset. And then finally it pre-computes all of the indices for this particular epoch for the virtual dataset. So that's what this is what this particular constructor does, and we wrap that finally up in this epoch batch iterator. And then when we call its frozen batch at the end of the construction, we sort the indices by target and source sample sizes, and then filter out the ones that are too long. So that's roughly the process. And there is a couple more steps later when we fetch the iterator. But I'm fairly sure that this process of adding the end of sentence token happens somewhere here. But let's see where exactly. Okay, let me see what's the best way to analyze this. Let me just drink some suspicious liquid. Okay, let's see. Later, the next epoch iterator calls a shuffle on the frozen batches from the iterator and does the sharding across the GPUs. And then we wrap that into the PyTorch data loader, and then that's wrapped up in the counting iterator. And finally, that's wrapped up in the progress bar. There is a lot of layers of abstraction here. But I'm fairly confident it does nothing happens here. So we don't add the end of sentence token here. It does the sharding and the shuffling. And then that means it has to happen somewhere here, but I'm not sure where. So let's kind of quickly analyze that again, just to see in the train script. Let's find the train script. And then let's go to get train iterator. Actually, the first one happens inside here. And then we wrap that into the iterator. And then we wrap that into the frozen batches from the iterator. And then we wrap that up in the counting iterator. And finally, that's wrapped up in the progress bar. There is a lot of abstraction here. But I'm fairly confident it does nothing happens here. So now the And then here is the get train iterator. So I'm going to just disable all the breakpoints and then put one right in here and then run the train. Let's kick it off. Let's just see where this happens. Where do we add the token? Let me also try and find the dictionary. Where is the source target dictionary coming from? So we can find it in the task, I think. So let me just see quickly. Intermediate. Here it is. Dictionary can be fetched from the task. So if we were to do this, I'm just curious to see. Let me just do something like this, and then EOS. Or no, let me see. How can we do this? PMP of 0 is what? So this is the start. So 0th index is start of sentence, and then 1 is pad, and then 2 is end of sentence, and then 3 is unknown, and then 4 starts being just random actual characters. So the first 4 are, as we saw, start, pad, end, and unknown. So that means if we see number 2, that means end of sentence. Let's go. Hit F5. Quickly, we're gonna go much quicker now because I'm already familiar with most of this. So I think we can just start entering here quickly. F5, enter. Okay, and then let's see what else. Now we can put the breakpoint here, hit F5, enter. Here as well, enter, and then load the split. So this is going to be the interesting part. And then here we actually can just step over all of this. That gives us the list. We'll have to understand why that's going to be a separate task. Let's just focus now on this one. So let's try and enter here. Enter here, load the dataset. Load the dataset. Is there any mention of the EOS here? Or BOS? I don't see it yet. We're gonna see. Let's hit F5, go here. Let's go all the way to where we need to enter. That's here. Okay, and then replacing BOS. We're gonna skip this one. Let's enter here. Hit F5. Okay, as I said, this is going much quicker now. Load the lang dataset. Let's see. Let's again enter here quickly. F5. Let's go. Train prefix. If train prefix exists, we'll load the source. Let's see. F5, enter here. Whoops, I made a mistake there. I should have entered. It would be so cool if we could go backwards. Step out. Why didn't anybody create an undo for the debugger? I wonder why. Okay, let's just stop the run. Disable the breakpoints and put the breakpoint here. Stop. Run train. Run this. Wait until we hit the breakpoint. Okay, here we are. Let's enter here. Load data, load index, just the path, infer the implementation, and finally make. Okay. Do init, that's where the fun stuff happens. Create the index, and then create the bin. And that's memory view. That's it. That's it. We can exit here. So there's definitely nothing happening in the mmap. There is nothing happening there. There is nothing happening there. Truncate the source, which is false. Okay. Let's go. Nothing happening there. We just append the same thing here. Load data, prefix target. Nothing different will happen here, I think. Let's see, I doubt it. Again, just get the path and then make the dataset. That's it. So nothing will happen here that's different. Let's just exit here. So that's it. We have now our mmaps. We log some stuff. We finish this. Okay, some asserts and stuff. We grab the datasets. Prepend BOS. We don't do that. We don't do this. We just retrieve back these two, and then we now transform them. So this, the transformation, what we do in the transformation is basically grab the token, which is the language token, and then we just prepend it. And that's all we do. So we increase the sizes here, and here we're gonna be adding token cat as a prefix. And that's it. That's it, guys. Let's go. We do the same thing for this guy, for the target, and then we end up wrapping them up here into this language pair dataset. Again, just some asserts and stuff. Nothing happens that's relevant to end of S token. We stack the sizes. Again, nothing informative there. Remove EOS from source, false. Append EOS to target, false. So we don't remove it from the source. So why should it be in the source? When I was tokenizing, did I add, maybe I added EOS during the processing phase, but I'm not sure. I'll definitely have to check that. Okay, if EOS is not none, then this, otherwise we grab the EOS. So here's the EOS. And then we go upwards. Let me quickly check where is the EOS used. Okay, in the collate somewhere. Somewhere during the collate function. And then here, iOS. Maybe here. Collate tokens, EOS. If it's none, otherwise we add it here. Move EOS to beginning. So that kind of implies that it was at the end already. Interesting. Let's put a breakpoint there. Let's exit. And that's it. Now we repeat that for this, the second data set, which is going to be, let's remove this. Just go up, go up, and go up again, go up again, and here we are. So we have two length pair data sets. And then we go up again. And then we just wrap it up into this sampled multi-data set. Let's see what it does. Call it format. Okay, nothing fancy happens there. Setup sampling, again, nothing fancy will happen there. We get the sample ratios. Okay, those came from above. Virtual size and then virtual size. Okay, we can exit all of that. We have our data, and then we have the batch iterator. Okay, so I still don't see EOS, and I doubt this is gonna add anything. This just adds this function, which I don't see it's calling EOS anywhere. So yeah, I'm kind of confused where the EOS comes from, but we're gonna find out soon. Let's see here. Is there any mention of EOS here? No whatsoever. Okay, exit. And finally reset dummy batch. This one is hello John. We're just quickly going through the dataset logic so that we can see where the EOS is being appended. I'm suspecting I might have added it during the data preparation stage in Stopes. But let's see. Okay, so sample. Yeah, we can kind of ignore this. This was this whole logic here that definitely did not. We just pick the ordered indices, that's all. And then later we're gonna filter by size, and then just order them by batch size. That's it. So certainly not there. So we can exit there again. Then we collate, and maybe the collate function will. Maybe the collate function will explain us where this happens, or maybe not. Let's see, the EOS is here. So it might be a good example to just try and analyze this. So let's grab one of the examples. So you can see here, it already has, so the source already has, and the target, they both already have end of sentence tokens here. And they also have the token here, which is the language token for the source and for the target. So this is the only content token here. Interesting. So let me see. So we need to backtrack. It's apparent that we get it from the frozen already. So we get it from the dataset already. Okay, so what I'm going to do is I'm going to switch the process to the one where we did not still get here. So I'm going to put a breakpoint here. And I'm going to go to here, hit F5, just run until we get to here. Call later. Let me think. First batch. Let me see what makes sense here. They are both in the first batch here. We entered in the collator. First batch entered in the collator. Why didn't I have a... Okay, I messed up here, I think. Okay. Let's put a breakpoint here and let's stop the whole program. So I'm gonna just disable everything, put a breakpoint here and rerun train. Let's see, once we enter there, what's gonna happen. Okay, let's go. Here we are. Frozen patch. Get the splits. Get the split. Get the indices. Batch by size. Append. Okay, we can actually exit here all the way here. Exit. Exit. Now here is the fun part. So let's start indexing into the dataset. Get item. Okay. Get the index and then call the get item here. Okay, let's go below. Let's go below. Pointer. NumPy array here. Okay, you can see this lowest level data. Okay, it's definitely the case that EOS was added in the actual binarized files already, because we already have the data here before we prepend anything or append anything. And yeah, that's the conclusion here. And now in the prepend, we additionally prepend the language token, but the end of sentence token was always there. That's the whole point. That's what I was trying to get to. I was just trying to find that piece. And now we just backtrack, and we keep on adding these. And then ultimately we're gonna collate them. Okay, stop this. Let's go to scopes. Let's go to scopes. No, let's close this. Prepare data. So let's see, where do we add end of sentence token? That can only happen in the prepare data stage. Let me close this. If we go to the prepare data stage, there's only a couple of places where that can happen. This just deduplicates in shards, and this one is the binarization, is where the whole magic happens. So here we call the get binarizer, and then we have this module, and we pass the config into it with this multi-proc line processor config. Okay, let's see, once we enter this one, the run file basically chunks, and we call the process file chunk. So we are either adding somewhere here or after in the actual merging procedure. Let's see. So here in the process, we instantiate this processor, chunker just chunks the lines, and processor is the main thing. Processor is the one that processes the lines. And then we call the final result. So let's see what it does. So processor is the main this is the main logic. Let's just find binarize again. Let's enter into this particular one and see what we do when we call run for the processor. Okay, so we do decompressed. Wait. Find the binarize again. Config and module. Oh, sorry. This is the actual one we're looking for. This is the line processor. Let's find it. And let's see what it does. When we enter make builder and process line, it's going to binarize the line using the binarizer, which is vocabulary dataset binarizer. So it binarizes the line and adds that one here to the builder. Okay. Let's see where we find this particular definition. I don't see it because maybe it's not. It's from the Fairsec binarizer. Wait. How do we find it? So the binarizer is going to be binarizing the lines and adding them. And then we just finalize. Huh. Let's quickly just run this. That's the easiest way. Because you can't step. It would be so cool if you could analyze like this, but it's hard. Okay, prepare data. Here it is. Here's the config. Let's just create some temporary output directory. And let's just focus on the validation. And we don't even need multiple of these. We can just comment out this one as well. Just focus on this, make it very, very fast to run. So let's go to prepare data. And let's just run with no args. Okay, run the prepare data with no arguments. Let's go. Hopefully nothing fails. I didn't miss out on something. Okay, just run F5. Here we are. Go to the build. Let it validate, and then we can go here. Okay, that was fast. Validation English, Turkish, and above we have English. That's it. Let's go. Enter binarize. Put a breakpoint here. Put a breakpoint in the run and just run. Just run. Just run until we hit the run function. Here we are. Okay. Run. Process file chunk. Run. Enter. Process lines. Here we are. Binarize. Binarize the line does the following. Append EOS set to true. That's it, guys. That's it. Append EOS. So this vocab, this is by design gonna be this vocabulary data set. This one is set to by the append EOS, and this is set to true in this object, which is called where. That's the definition. mmap. We didn't specify, we just specified the vocab file path and SPM path and dataset implementation. And because of that, let me just see. Okay, then the EOS token comes from this guy. How do we specify this object? How do we specify? How do we instantiate this one? So I only see it here. And we call it with two paths and dataset implementation. Two paths and dataset implementation. So this is true by default, which means this is going to have true by default. Binarizer has true by default. And now when we do binarize, let me show you what happens. We encode the line. We pass in the line. We pass in tokenize. Let's enter if we can. Line tokenizer. Okay. And then we index word by word. We pass that to the consumer, whatever that is. So let's see. Consumer. And then we append. And then we let that go by the very end. And then we append number 2. And then we get the tensor. And finally, we retrieve that back and add it to as the item in the mmap dataset. We write it, and that's it. So that's where the magic happens, guys. That's now clear. Let me just remove this to do. And I think we do the same thing for both the source as well as for the target, right? We're gonna do the same thing for both the source and for the target. Let me see that. I don't see why it would be different. Why would it be different? Let me see. Go back to binarize. Go back to binarize. So we have both the source and the target. We both, yeah, it's just indiscriminate. It treats that file no matter, it doesn't know whether it's source or target, so it just treats them both the same. So both will have the end of sentence token there. Cool. Now one more task that I was wondering about is why are we loading on a single shard in parsec? Let's go and see that. So let's go to not the Stokes, but let's go to fairsec. And this is actually a potential reason why we were iterating so fast during the training. Because we literally only had a couple of millions of lines of sentences as opposed to 36 or something, and for Turkish and 3 more for Hindi or something like that. Let's go to train. Let's go to load checkpoint. And let's understand why are we loading a single, just disable everything. Why are we loading a single shard? That's completely unexpected. Go to train, run. Okay. Enter here. Load the data. And then call the batch iterator with the data. So in the load the data, we should find the answer. Okay, load dataset. Why are we just passing through training? That makes sense. Combine, true, whatever that means. I'm not sure still what combine means. Data selector none. Let's go up there. Let's just toggle on all of the breakpoints. Let's enter. Split training combine, shard epoch, empty. Data sets. So I would expect to have a ton of different data sets here for all the shards, but that's not happening for some reason, and I don't understand why. Shard epoch, again, keyword arguments are going to be empty. TPU false and the data selector is none. That's like not vital for understanding here. Okay, so now here we end up with only, if I recall correctly, we end up with only shard 0. If we were to just ignore everything, disable, and just hit F5 here, we end up with, as you can see, main dictionaries, and we end up with this shard 0. Where are the other shards? How are we supposed to extrapolate from here? So I would expect to have many more shards, but this is not working for some reason. So let's switch to the second process, run F5. Let's now enter here. So data path does return all of these shards. So far, so good. And then this also tells us how many shards we have. So far, so good. And then we go here, we split the paths. Yes, sharded data true. Everything looks good. Everything looks good. We have directions, language directions. We go here. We grab the key. And then get split data path, get shard ID, number of shards, shard epoch, epoch 1. Let's enter here. So why are we retrieving just a single shard epoch is none? So that means if it's none, then we retrieve epoch, otherwise we retrieve shard epoch. So we just retrieve 0. And because we retrieve 0, we retrieve 0th path. Okay, and then we just add it. And so by the end, we just have 2 paths and all of them are shard 0. Why does that happen? Shouldn't this data path give us back like more of these? Oh no, we index here, and this one retrieves literally just a scalar. So by definition, this get split data path is gonna always retrieve a single path. Get split data path always retrieves a single path. So to get more of them, we'd have to iterate through more options here, but that's impossible because this only specifies language directions. Okay, let's go. And now that we have this list, do we ever reevaluate? Do we ever consider loading from other shards inside of this dataset here, load dataset? Let's see. Combine. Path is going to be only 0. So let's see that data path. It's only going to be 0. Go here. Let's enter here. Let's continue. Let's load lang data sets. Then we transform them. So this is gonna give us back the mmap. This is gonna add the prepend. And then we just wrap them up. So if we're dealing with train subset, we enter here, see that the split exists, grab the file name, make sure this exists. If it exists, we create the train prefix. We create the train prefix. So it's literally meant, there's no for loop, right? It looks like it always assumes that we have a single path here. So it looks like this should load only a single shard. So where does the multiple shard loading happen potentially? So here, full path again, load, path, load this, path, get the path here, make the data set. No mention on multiple shards. No mention whatsoever. Okay. So let's continue. That's the source. We can just exit or let's see where we are here. Just continue here. If train split is in here. Data path. Always the same data path. Weird. Definitely looks like this one was meant to only have append the source data. Append as well. Train prefix. Okay, so how does one load multiple shards here? Train prefix is set like this. So it's obvious that this one can't change its shard information. Okay, let's go up. Let's go up. Let's just go up, up, up. Language pair dataset for a shard. Something is not clear here. Okay. There is no for loop here. I don't see how they supported multiple shards anywhere. Definitely not here. Let's then exit. Let's continue. Okay. And then batch. Get the train iterator. Okay, something's weird. I don't understand. Let me see whether somebody complained again about this already. type error. I'm looking for some error that suggests that somebody else couldn't load sharded dataset. Okay. Let's see. Sharding an already pre-processed data bin, maybe this. Huh. Okay, let's see. Any mention here? Out of memory for sharded data. How does one even load sharded data? Any mention of shards here? Could it be that? No, I doubt it. I'm just thinking whether we might be loading different shard the next time. That might be a solution. Let me see. When we are here, is there any mention of shard here? Shard ID. Number of shards. Go back to train. Train step. Train. Get the next train iterator. Disable next epoch index. So this changes the epoch, and that changes could epoch be changing stuff? Because I don't really understand. We're wasting all of that data. Crazy how much of these silent errors, like, so I ran the previous training and it turns out we were only training on shard 0. Okay, let me just notify people. for Hindi and Turkish, we were only training on a single train shard of data, and we actually have 28 shards for Turkish. Not clear how we load the other shards and when, if at all. Okay, I mean, that's gonna be additional community task if I don't manage to solve this myself now. Okay. Something weird is going on with my GPU. Let me just check the... Why are you running on 70 degrees and 300 watts? I'm not training anything to the best of my knowledge. So just by the very fact that this is running here, it's complaining. Interesting. That was 300 watts of just eating power. Definitely not clear what's going on, guys. What happens with all of my shards? Give me my shards. Train, load, checkpoint. It's a good thing I've been debugging this, otherwise who knows how many of these regressions would be hitting during training. Okay, rerun. We have to figure this out, guys. So this is get train iterator here. The thing that changes is epoch. This will always be has sharded data. This will always be true. This will always be disabled true. So epoch is changing from every time we loop here. Okay. Let's kick it off again. I have to find this out. I'm just going to grab some water while we're waiting. Let's go. So what's going on? How did we end up here? Aha. Because we are running all of that. We just need to disable and enable only this one. F5. Okay. I had a harder workout, so I have to drink a lot of liquid. Let me see here. Task has sharded data. This should always be true, right? And okay. So Kevin said that if we enter here, suffix, reset, checkpoint, blah, 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 blah. Load checkpoint. Go here. So again, this is set to true. This is going to be set to true. Again, disable this cache. So the only thing that changes is epoch. This one, the first one is always set hard-coded to 1. So what does that change? Epoch. Epoch is passed in here for the seed. Skip the reminder. Blah, 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 blah. So things change here in the task. So where is epoch gonna change things? Okay, so if split is in dataset, which it's not, what's the shard epoch? Virtual epoch. This might be, let's see. If split is in the dataset, which it's not, estimate global pass epoch. Estimate the shard epoch from virtual data size and virtual epoch size. What's virtual epoch size? And why is it set to none? Virtual epoch size. Let's see what that is. Just close all of these. Wait. Virtual epoch size. So all of these are just like random files. We don't care about those. So where is it actually used? If it's not none, load the next shard. Change the shard epoch. I think, that might be it, guys. That might be the explanation. Let's see. There is a ton of eureka moments on these streams. Virtual epoch size. Okay. Multi-epoch. Sampled multi-epoch. Okay, let's see how it looks like when we add dashes. Where is it used? Virtual epoch size to speed up data loading. So this looks like more of a speed up technique than anything else. So let's see, sharded data set. Support sharded data sets. Paths. And then, wait. So epoch here is gonna be, we're gonna be modulo doing here for the data path. Wait, are we hitting this code path? If we are, no, we're not. This is truncated. Let's see some random stuff that we never hit for sure. And same here. So this was like this was the only piece of code that I've seen that looks like it's suggesting that we're using different paths. Then loading truncated BPTT dataset. So what's the thing with this one? What's the thing with BPTT truncated? Big propagation through time, I guess. What does that have to do with anything? In very long sequences. Nah. Let's go back to searching sharded data set. Sharded data. Nothing there. Nothing there. Crazy. I mean, literally the only place where I can expect this to happen is in this load dataset function. So get train iterator, as I said, always gets called with the same arguments, epochs. This is always true, and this is always true. Shard batch iterator, yes. Load data. This is like the only place where all of this can happen. Enable breakpoints. Let's just enter here. Hit F5, enter. Load sampled multi. What does this one do? Speed up data loading. This definitely seems to be only an optimization technique. They don't mention multiple shards anywhere. And then, we need this line. It has to happen here. and then we retrieve back a bunch of data sets, and then inside of this one, we just estimate how we sample from those data sets using these sample ratios. So we grab the data sets, we use them to get the train sampling ratios, we get the dataset sizes, and then we get the sample ratios from there. That's my only explanation of how this could happen. Virtual data size, no. That's it, there's no other way. If training, and we are now training the, okay. Let's enter here. Why don't we get there's literally a to-do here, guys. To extend with extra datasets and keys and loop over different shard data paths. There is literally a to-do here. Otherwise, we're just using the shard 0. Let's see whether anybody changed this in newer versions of AirSec. Because otherwise, as I said, we get data paths, that's cool. Here are all the shards, yes. But what do we do with them? We just get a single concatenated shard with columns. So is there a bug here maybe? Data paths, grab the data, and we just return it back. That's it. So we just come here, we grab the data, and we retrieve that back. And then here, we get the shards, we split the paths, I will never loop here. We just grab the key, grab the data path, and then we chunk it in here. Definitely something this is not ready. So yeah, this one also gives us a single shard ID. It works by, if shard epoch is none, which it is, then we retrieve back epoch. Huh. Huh. Ha 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 ha. Okay. So could it be here that number of shards is always going to be like this? Shard epoch is always going to be none. Ah, okay. Okay, wait. So we get what? Because this is none, we retrieve back the epoch, and that means this will be going up and up every single time, right? So shard here is now set to 0, but let's put a breakpoint there. So we retrieve now the shard 0 and we append it. Okay, we go up there, we load the data. We just load the data. So we load the data, hit F5. So we loaded with shard 0 in the load dataset split. That's it for this time. And now we just we go and pass that into the multi, and then we go here. Again, here is going to be, where are we here again? Because sampling ratio apparently requires this. Okay, let's go. Let's go. Okay, let's go. And that's it. Multi. So this one gave us the multi one. Okay. Will we be calling this function again? Load dataset. Get batch iterator. And that's it. Now we have the data. Now this is just the batch iterator. That cannot change the fact that we did not load the right shards. So hit F5. Remove this. Remove this. Remove this. Remove this. A ton of debugging today. Okay, exit. And so this was the call to get train iterator. Okay. So let's see when we call it the next time. Get train iterator is going to be called here again. So let's see when we go. Let's see, just hit F5, let this run. Remove this. Just let all of this run. Let's just remove all the breakpoints other than this one. Run. Run. Okay. Let's see. And we also need to, just to make this faster, before we go there, just to make it faster, I want to disable my functionality here. This one, just make it a bit faster. We don't need that one. Run train. What is setting the number of updates to 1000 before we cross to the next epoch? What's that setting? We can maybe make it a bit faster so we can iterate quickly. What is set to 1000 here? Something is set to 1000. Max updates. Save interval. I guess it's just the size of the shard. I mean, that's the definition of an epoch. Okay, let me stop this again. Restore 2000. Let's restore the interval update 2000. Restore this to 12. No, we don't have to. Okay, now we're good. Now we can just run train. Kick it off. Let it run a bit and let's see whether I made a mistake potentially. Okay. While that's happening, I'm gonna go to the latest fairsec. Let's just open it up. Fairsec. Go to the main branch and find that particular line of code, which was, how can I find it? Get split data param list. Get split data param list. So this is inside of, let me just open this up. Data multilingual data manager. So let's go to, again, VirSec. Then go to data, go to multilingual, go to multilingual data manager, go to get split data param list. This does not look like anybody touched this file in a while. Not really good news. Let's go and see the history. I see last year. So somebody touched it on May 24th. So let's see. For us, this is gonna be okay, let's just see here. Git log. Can I just do this? February 7th. Copied. February 7th, 2022. August 2022. Okay, so August 29. Let's find the March. This is July. Let's just keep on going. July. Okay, there's gonna be a ton of stuff here. And then February. Huh. So this happened on July 6th. We should have all of this included already. Let me double check. So on line 73, there is this mention of unexpected file version. Aha, that's not the right file, wait. Multilingual data manager. Target. Line 922. Multilingual data manager. Okay, somebody might have changed this since. How can I see the last update to this file? Can I do something here? Debugger, source version, changes, application, git, see history. Can we somehow see the history here or not? Wait, guys, why didn't we stop on the... Why didn't we stop here? What is going on here, guys? Why is this so shitty? Why is my computer glitching so much? Where is the epoch information? It started with 1. See, update. It's growing, but it's very, 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 very slow. Okay. Let's just reduce the amount of data. Let's just reduce the amount of data. Let me just stop. Okay. So I'm gonna do 2 things here. First of all, I'm gonna make this a super small transformer. This is like painful to debug. I don't wanna do this to myself anymore. So let's just go here and put this to 3. Okay, and then I'm gonna next pick up return back the Turkish English. So I'm gonna just pick only this one, only Hindi Java. Okay, and this should now be faster. Run, and let's see. So I was at figuring out how to see the latest change to a particular file. Let's see. Git, how do we find the latest update to a file? Why are you complaining? Okay. You're complaining because there's already a checkpoint. It's trying to load it, but we changed stuff around here. So let's just delete this whole thing. Rerun. And let's go and find this. So git log. So we can call it like this. Okay. That's all I wanted, really. I need to now find this file. So let's do this. Here. Copy. And get the file path. Y. Okay. Get the file path. Just making sure this one is here. Okay. Find my. Okay, swear to God, I'm gonna just close out all of this. Too much junk. Just close all of this and just open green. And then I'm looking for the file this was called get split data param list. Get split data param list. And the file here is called this one. So let's just copy the path to this one, copy path, and see what happened to this file. So the last update was on July, and then before that it was updated on November 29th. Of 2021. Okay, so that means they branched out, and then they, because we're on the NLLB branch. So let's see. On the other hand, wait, well, let me see how much memory I'm consuming with only 3. Like, this FSDP is like so shitty that it's crazy. Watch. Like, why are you eating 90 gigabytes with 3 layers? Like, crazy inefficient implementation. Okay. Okay. Let's see. How does the history of this file look like? Looks like this. And we had here what? Again, please. Show me this. November 29th, add linting with black. Add linting with black. Okay, so the only change to this file that happened since was some f-string refactoring stuff. Okay. So having said that, there is nothing we can import from latest updates to FairSec to extend with extra datasets and keys and loop over different shard data paths. So we can definitely do that. Because effectively, so that means that we effectively have to do 28 epochs. We have to do 28 epochs to actually do a single actual epoch over the whole data set. 28 for an actual epoch. That means 28,000 steps for a single epoch. So we'll have to train this a lot. Let's see how we're progressing here. Saving a checkpoint. Where do we stand with number of updates here? 1000 epoch 1. Let me see. When are we going to hit the next run? When the train is over. And train is over when what? When we deplete the progress. How can we track that? So those are some details I really need to know, because otherwise it's a struggle. I need to know exactly when the epoch is gonna, when this loop is gonna end, so I can estimate stuff. So it says update 0.573. I guess that's the ultimate thing we're looking for. We're looking for this epoch, for this update parameter, and once it hits 1, that's when we transition into a new epoch. So let's see where we call this update. Update. Okay. Here we are. Round the update. Format stats. Let's maybe put the breakpoint here quickly and see what's gonna happen once we hit it. We're now 0621, and now we're gonna be 0668. Okay, so who passed me that info? Okay, here we got it from here, and we got it from get precise epoch. And to get that one, we see what's the iterator size and count. So for train, we call the logs. So for train, number of updates is a step. Okay. So we get the stats, we get the epoch, and we get the update from here. Size of the iterable is 2000. So 2000 batches, which makes sense. Roughly. And now we are at step I. Okay, let's just run. Let's run until we hit the next breakpoint. Okay. We're here. 1502 2099. We just log this on the side. Quickly log that on the side. So we are now I equals 1502, and this is always going to be 209. Size 2099, and epoch is always going to be 1. Okay, let's go. Rerun. Almost there. Okay. And this is now 1602. Got it. So it's being incremented one by one, and then we log. Okay. Fair enough. That's how we figure it out. Run. So we're just tracking the number of batches and comparing that to the total batch size, total number of batches in the iterator to get the update. Okay, soon we're going to hit. I could have used a smaller dataset than Hindi, which is still, as you can see, we have to wait a bit. I can next up just switch and just use some dataset that has a single shard that's like smaller than Hindi. Almost done. 0859. I take the learning from today and write a doc on how data pipeline looks like during training. I guess it's Sunday. People are not really super active. Next week we'll have new cool guest speakers. I'm still thinking who is the best person for the next talk. I reached out to a couple of people and then we'll see. Okay, guys, here we are. This is the moment of truth. The moment of truth. Let's see. Let's now enable all the breakpoints. Whoops. Whoops. Enter. Let's go. Let's go here to the train load. Let's go here. Shard epoch. Aha, so now we have a bit different because this already exists. So we just load the dataset and so we loaded the multi dataset, and then if it has sharded data, which it apparently has, in that case we change the shard epoch to 2. Let's go. So it now says epoch 2 out of 2. Whatever, a bit of misleading. So we delete the manual. Okay, so we manually delete the dataset. So I think this is gonna be it, guys. This is gonna be it. This is gonna be the explanation for how this works, guys. Let's go. Let's go. Let's go. Load datasets. So this is where the magic happens. Enter here. Enter here. Enter here. And see where do we just think. We just grab all of the data paths. This is not the interesting part. We can just exit here. So we get all of the dataset paths here, all of the 28 shards. And then get split number of dataset shards. Okay, 11, that's true. And then split the paths, that's fine. Let's go, let's go, let's go. Just iterate over there. Keys, get split dataset path. So this is where I think things start getting interesting. Exactly. Exactly. So shard epoch, if it's none, then epoch, otherwise shard epoch. So we end up with shard 2 here. So that means shard is equal to 1 here. So that means in return that we've indexed into path shard 1. Exactly. So we get that path now. So let's exit. So we ended up with this new shard path. Shard 1. That's it. That's the explanation, guys. So we deleted the old one and we went on to load a new shard. So now here we load a new dataset with a new shard. And actually, let's just see quickly. Let's just disable everything. Enable this one, pick the second process and just kick it off until we get here exactly. Let's just enter here. So again, here should also be shard 1. Let me just double check that this is shard 1 exactly, and it's saved here as the data path. So we would enter here, we would enter here, we would enter here, we would have the data path being loaded here. Again, enter here. Data path is going to be loaded where here? Okay, if it exists, then we create the trim prefix, which is going to be shard1 this time, exactly. And if it exists, then we load from here. That's it. I can stop this. So, yeah. Okay, figured it out. False alert. We are indeed using all of the shards, but the trick is we have to go over a whole epoch before we load shard 1. So effectively, that means that, for example, for English, Latin, Turkish, Latin, we need 28 epochs because it has 28 shards to go over the data set once. Effective epoch. It will vary depending on the language direction. Okay, in case anybody cares, I wrote it down there. One thing I also want to understand is, because we have multiple data sets, each of them has multiple shards, number of shards. How is that gonna look like? For that, we can just we can just rerun until we hit disable this, until we hit the get train iterator. So let's kick it off again until we get here, just to see how we're dealing. If we have multiple language direction, each of them is going to have different amount of shards. Are we going to just cyclically go over them? In which case, some of them will oversample just by the very fact of yes. So we should not use any temperature that's above 1. That's the thing. Because we'll be overfitting on smaller datasets faster, on smaller directions. "40 minutes ago, I'm ending the stream in 11:30 exactly, because I have to wrap up some other tasks off the camera as well. Let's wrap up this. Let's write some documentation and start adding some tasks. Okay, let's hit the... Wait, where are we not? Oh my god, wait. Of course we're not, because we again have this annoying dump location. So it just loaded the data and went a different code path. How are you guys doing? Enjoying the Sunday? In Serbia, apparently we had 4 different sport teams playing some championship on like the highest level possible, like Novak Djokovic, like playing tennis, basketball, apparently some finals or whatnot, volleyball as well. So people, I was just like, during the break, I would go outside and I would just hear people like shouting all across the buildings. Everybody watching all of the games during the day. Crazy stuff. We're truly a sport nation. People love sports here. Load data set. Okay, so where were we? We want to go here. Let's enter the task. Let me just enable the breakpoints quickly. Let's enter here. Okay, so the question was, okay, shard epoch. It's gonna be none, but we're gonna have epoch. That's fine. So load the data set. Split data sets, enter. For different directions, right? Let's enter here. Okay, so load split dataset. So this is where the whole magic happens, and then we just packed it into the sampled multi-dataset. Let's go here. And then again, here we just load. Here we pick the actual path. So let's see how this is gonna look like. I'm fairly sure I understood it correctly the first time, but let's double check. So get the paths, get the number of shards, that's fine. Okay, ton of paths there. Let's see. So here we get, for this particular language direction, we enter, and all of them are going to give us back. This is going to be the same for both languages. If we assume we have Turkish and Hindi, this is going to be the same. No, I'm lying. This is going to be different. This depends on the language. It's going to be the thing that's being used as a modulo here. This will be the same, and this will be the same, right? Because if we take a look here, shard epoch will not change across the loop, and epoch will not change across the loop, obviously. So epoch and this will not change. So that means effectively here, initially we'll get 0, and then the second pass 1 and 2 and 3, but we have modulo. So that means we'll be iterating over the shards of the smaller language direction much faster. And that means we'll be oversampling that one much faster as a consequence. Exit here. That's going to be the case. So here we have 0. If we had Turkish as well, both would be 0 shards. But then because Hindi has 11, Hindi has like 11 shards, with hit 11, Turkish would be 11 or 10 because this is 0 indexed. And then once we hit the next, in the next iteration, when we have like 12 epochs, in that moment, Turkish would be 11th shard, and Hindu would be like 0th shard again. So we'd start the looping process already. So we start repeating and seeing the same data. So effectively, the epoch has already ended. So yeah, that's a problem. That's a problematic thing. Okay, we can stop now. I have all of the answers. That's a bold statement. Okay. That's the conclusion there. Let's see. What can we do about that? And what should we do about that? Not sure. How many? So we definitely should not increase the temperature over 1. We should even maybe reduce it. Or just change the way we do this. Let me think. What's a reasonable thing to do here? What we'd ideally want to have is well, ideally, we'd have to have a curriculum. Yeah. That's why we must have a curriculum. The paper stated 4-stage curriculum, i.e. include these smaller directions only later during the training to avoid overfitting. Awesome, guys. This was amazing learning. I really enjoyed the whole day. Learned a ton today. I think more than usually. I figured it out. So here are the next tasks. Write the document and add tasks to the GitHub project. So that's going to be a bit easier wrap up of the day. I'm going to make a short break just to stretch my legs, and then we can continue. These are the next steps. Let me just put a note. Short break, 3 minutes. Be right back. Okay, guys, see you in a couple of minutes. Let's go. Okay. Document describing how data loading in Fersec works for machine translation. You can learn more later when needed. Okay, first of all, let's just grab this. Let's open up Fersec. Getting started. I'm just gonna put a this, and I'm not gonna take too much time. I'm just gonna write some stuff that are also useful for me as well. Explanation of the data loading pipeline in Fersec of the empty machine translation data loading pipeline in Fersec. Okay. Should be fairly short one. I'm just gonna grab this and just put this as my notes. These are gonna be my notes here. Like page data loading. Just dump it here. Go back to to-dos. And okay, we are back here. At the output, at the end of the data preparation. Oh my god. Stage in slopes, we end up with sharded binarized language directions. Example, what it means is take English, Latin, Turkish, Latin as an example. Let's take this language direction as an example. It has 28 shards. The train dataset has 28 shards that can be found, that are organized in the following structure. Basically, we have the data bin, and then we have like shard 0, and then we have, let me just see, quickly go to stopes again. Here we are, data new, data bin, shard 0, and then here it's going to be, as you can see here, English, Latin, looking for Turkish. Here it is. Okay. Here it is. These 4. This is going to be the first one. And then we have the index file for that one. And then we have Turkish. And then we have the index file for that one. Okay. What else? What else? What else? Okay, that's the shard 0, 0, 0, 0, 3 zeros. Okay. Shard 0, 0, 1. Same, and then same here, and then shard 0, 27. Okay. That's how it looks like. I'm gonna put this in the coding formatting. Okay. In Stopes, we end up with sharded binarized language directions. For example, let's take as an example, the train dataset has 28 shards organized in the following structure. Okay. Bin files contain tokenized sentences. We use SPM 200 tokenizer. That's it. All of them are suffixed by an EOS token. Labeled like this. That has a numerical, it has index 2 in our dictionary, in SPM 200's dictionary. Index files contain number of tokens per sentence from the bin file. That's my understanding. Let me just recall, did I mess it up there? I don't think so. Yes, it just grabs the size. Maybe, let me see, where does it include EOS or not? Binarize, get here. Run process file chunk. Here we are. Will it add index? Well, there is one way to find out, and it's the quickest way. Just run it. Just run it. I'm gonna get here very quick because I've already minimized the amount of processing we have to do, so it's gonna run very quickly. Here we are. We're already in the binarization. Okay, so now process file chunk. Let's just end up here. Okay, now process line. And on exit, we go here. On exit, we finalize. And so what do? We have a suffix. Okay, and then name, old suffix, new one. From parse parts, what do? Let's see. This is irrelevant. Okay, this is relevant. So index, open it up, writer. We open it up, the file, the index file, and we write some headers initially, and then we start writing. And what writing does is we get some sizes and we basically write those sizes into the file. That's it. So file gets, we write some header, the sizes, the pointers, and then we close it. So the ultimate question is, what are the sizes? What are the sizes? Sizes are this. And what are those? Those are basically created by this here. So we have to go here. Let's wait until we hit snap. We already finished, so it was very fast, as I said. Data, prepare data, exactly, rerun it. Let's just hit that line. So I'm certain I'm writing good documentation here. Okay. Almost there. Let's hit that particular line. Unless something went terribly wrong, we should be way on our way up there. Why are we not hitting this? Okay, we already ended because we have to change. Okay, we have to change quickly. We have to delete this. At least we have to delete the data bin. And let's rerun. Prepare data, kick it off. And let's get to the breakpoint just to see whether those sizes include EOS or not. That's the question there. Okay, F5, run, chunker, run, append, here we are. NumPy array, blah, 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 blah. We write it. What's the last 5 tokens? Okay, as you can see, last 5 tokens are, it ends with 2, it ends with EOS. Because that one came from process line. And here we saw already binarized line. This guy already adds EOS, and then we add that as the item. And so we append the size, and the size is gonna be whatever the shape of this thing is. Array shape is 57. No, this is gonna be, sorry, this is gonna be the size in bytes. So I had a misunderstanding there. So this is gonna be, wait, are those the same? They're probably not, because this is unsigned integer 32. That's how I understood it. So when you take empty array and you call size, you get the number of elements, right? Not the size in bytes. Let me just see again. NumPy size. NumPy size, number of elements in the array, exactly. We're golden. We can stop this. Insight acquired. Let's go back here. Contain number of tokens per sentence from the bin file, including the EOS. Maybe we can do it like this. EOS token. So again, bin files contain tokenized sentences per line. All of them are suffixed with an EOS token that has index 2 in SPM's dictionary. Index files contain number of tokens per sentence from the bin file. per line, aka a single number per line. The language code just before the suffix tells us which language sentences, which language that bin index files contain. Okay, that's it. Step 2. The lowest level of abstraction. Okay. So, next up, we load the data from the above bin/index files into mmap, or memory mapped dataset. It helps mmap TLDR. Mmap helps us to deal with datasets whose size can fit in system memory, RAM. It handles loading from the disk into the memory. From the disk, whatever the disk is, HDD, SSD, whatever, SSD. Okay, the lowest level of abstraction is, okay. Headers, pointers, bytes. It's the lowest level of abstraction. And it deals with headers, pointers, and bytes. Deals with headers, pointers, and bytes from bin and index files. Okay, in a bit more detail, if we go here, we can save this. Let's see, multilingual, where is the mmap defined? Mmap index dataset. Okay, I think this is the one. Okay, so here you can see how it works. Init and stuff. So version, this is to open it up. Version, and then data type code, and then length and offsets, and that's how you grab the, at the end you grab binary buffer. I'm gonna also link the implementation so people can look at it. Headers, d-type, and stuff. Okay, what is this? Why is this thing? memory mapped. Okay, its implementation is in here. Copy the path. Whoops, actually I'm already in the right place, so I just need to go here. You can find its implementation under fairsec here. Then goes step 3. We then wrap the mmap dataset for both the source and the target language into prepend dataset. As the name suggests, it prepends the language tokens to all source and target sentences, to all source and target binarized sentences. Okay. Now let's find the definition. Here it is. It just adds the token, as I said, and it's located here. Copy path. I mean, I'm not sure why I'm copying the paths. I should not be copying the paths because they might change. Okay. So at this language tokens, let's quickly explain what language tokens are. Language tokens look something like Hindi, Hindi, Java, something like this, and have their own corresponding index in the SPM dictionary. So at the end, the source sentence. So at this point, the source target sentence might look something like this. So like some big number, like, I don't know, 260, 58 or something, followed by, I don't know, some numbers. Length token, data tokens, EOS. EOS, length token, data token EOS, something like this. That's it. 4. We then wrap the source target, prepend token data sets into this abstraction. Five. We then wrap multiple of into sample multi-data set. This data set additionally assigns a sampling ratio to each of its subsets. Okay, this is going to be intensive, but hopefully useful. Almost done. Okay. Thanks, Tarek, man. Appreciate that. This dataset additionally assigns a sampling ratio to each of its subsets based on the size of the subset. For example, if one subset has, I don't know, like 75 million sentences and the other one 25 million, the sampling ratio coefficients will be 0.75 and 0.25 respectively, unless we modify the temperature. That means we'll be sampling 3x more data from the bigger subset proportionally. Okay. But if we change the temperature from 1 to something below it, it also computes the virtual size of the data set. Now that we potentially upsampled or downsampled some of the language direction subsets, it finally pre-computes all of the indices and shuffles them and randomly permutes them based on some deterministic way of configuring the random seed. Okay, 6. Next, we wrap this into this. Okay. At the end of the construction process, we call okay. Almost there. Almost there. But this looks very, very information dense. I mean, it's hard not to be dense. At least we have some information. Okay. I'm gonna wrap up very soon, guys. I have to do some other work as well. Let me just check one thing. Oh my God. Okay. Okay, I'm just gonna put VAP. Okay. I'm just gonna submit it as this. Better than nothing. And then I'm gonna wrap it up tomorrow because I really have to run and do some other stuff. So can I just go Q, exit, okay. Status. What do we have? What do we have? We have data loading. Data loading explained. Something like that. I'm not sure what's the best way to call it. Okay, and then what else? YAML, ignore. Train.py, did I change anything there? Copy, get diff. Let's just see whether I have anything different there. Okay, I just commented out this. I don't want to check that in. That's it. We just have this thing and commit and say add explanation of the empty data pipeline in fair-sec. Okay, I have 1 M more than we need. And then origin. Okay, and then let me just add this. Nice. That was some awesome work today, guys. Write a document describing how blah blah. Wrap this up. That's it for today, and then I'm gonna add tasks. So I'm already making some progress there, guys. Those of you who are new here, please join the open NLLB channel. That's where everything you need to know is contained, including the pinned documents which you should check out. Let me just go to GitHub. We keep on getting more stars here. 45. So here is the data loading explained. We'll probably migrate this somewhere else. Learnings from today. Ton of details, but hopefully useful once you start digging deeper into the code base. We'll wrap it up tomorrow. There is still some sections that I haven't finished yet. Hope it helps. Okay, guys, that's it. Amazing day, super productive. I think at least 10 hours of working on the camera and then off the camera as well. And I still have some work to do, so it's gonna be very, very, very fun. Anyways, see you tomorrow again, 10:30 a.m. Central European time. Let me see whether I have anything in the morning. I have some meeting earlier in the morning, so that's fine. That will not affect the schedule. So 10:30 a.m. CET it is. Cheers, guys. Have a good night. Have a good day. Have a good evening or morning, wherever you are, and see you tomorrow. Cheers.